Hello, welcome to the new topic, maximum power transfer theorem. We need energy sources in order to energize the circuits. Voltage sources, current sources, etc. are required to energize the circuit. While using such sources, generally we don't consider its internal resistance if it is not given. Okay. Here, according to the maximum power transfer theorem, the maximum power will be delivered to the load only if the source resistance and the load resistance are equal. Let us demonstrate this concept using a circuit diagram given below. Okay, suppose we have a voltage source and corresponding resistance Rs. Okay, resist is source resistance, means the internal resistance of the voltage source. Okay, now we are going to connect this source to a load, say load resistance RL. Okay, and according to the statement of maximum power transfer theorem, if we connect a load to a source, maximum power from the source to the load will be transferred only if the source resistance Rs equal to RL. Okay, got it. In order to prove the statement, we need to know the power that is developed or power that is delivered to this load or power developed across the load resistor RL. We know that the simply equation for power P is equal to I square R. That is the basic equation for power. Just keep this in your mind. So, in order to evaluate the power, we need to know what is the current in the circuit. Okay, right. So, first of all, we have to find the expression for current. All of you know that the basic equation for the current, that is equal to potential difference divided by the total resistance. Okay, right. So we are going to find the current in the circuit. Okay, current in the circuit I. Okay, current is equal to potential difference. What is the potential difference in our circuit? That is Vs divided by resistance. What is the resistance? Rs plus RL. So we got the expression for current as I is equal to Vs by Rs plus RL. Okay, right. Let us mark it as equation number 1. Now let us find the power delivered to this load or power developed across this resistance. Power delivered to the load is P is equal to, basic equation for power is I square RL. So in this case we can write it as I square RL. Before proceeding, let us mark it as equation number 2. Now let us substitute equation 1 into equation 2. Okay, now we are going to replace the expression for current using equation 1. That is what I have written here. Then the expression for the power changes. What is I here? That I is Vs by RL plus Rs. Okay, put a bracket as we have multiple times. Square. Okay, square. Then RL. Now we got the expression for power developed as V by RL plus Rs whole square RL. That is equal to Vs square divided by RL plus Rs whole square. Let us rearrange this equation in this manner. Then we are getting P is equal to V square. All of you might have heard about the concept of maxima and minima in engineering mathematics. Okay, in order to find the maximum value, what we have to do is just take the derivative first, just take the first derivative and equate to 0 and solve. To determine the value of RL for the maximum power that should be delivered to the load, we have to set the first derivative of this equation with respect to RL, then equal to 0. Okay, that is written here. That means to find the value of RL for maximum power, we have to find the first derivative, means d by d with respect to RL, in the sense d by d RL of power. Okay, right. You have to take the first derivative of this equation number 3 with respect to RL, then equate it to 0. Now using equation 3, we can write, modify this equation as d by d RL of, instead of P we can use the RHS, that means Vs square RL divided by RS plus RS the whole square. Okay, that in order to solve this one, we need to know the quotient rule of differentiation. Okay, right. Simply speaking, this is the quotient rule. Um, Denominator into derivative of numerator minus numerator into derivative of denominator, all divided by denominator the whole square. That okay. Now let us apply the quotient rule of differentiation in this equation. Then what we are getting is first denominator. What is denominator here? That is RL plus RS whole square. Denominator RL plus RS whole square into derivative of numerator into d by d RL of, what is numerator here? Vs square RL, Vs square RL. Okay, then minus numerator into, what is numerator? Vs square RL into d by dRL of, d by dRL of denominator is RS plus RL all square. Okay, then all divided by the whole divided by, what is denominator square? Denominator is RS plus RL all square, RS plus RL all square. Denominator square, we have to take the square of denominator, then I have to take the square of this denominator again. Okay, then that should be equal to 0. Now we have to find the solution for this expression. Simply let us take the denominator, entire denominator, 10 to the RHS, then that will be multiplied with 0 and the RHS will be 0. Okay, that is what I am going to do. Okay, the entire numerator that is written here, and I have taken the denominator to the RHS, then that will be multiplied with this 0 into RS plus RL square the whole square. The entire RHS will become 0. Okay, now the entire RHS will become 0. Now we have to find the solution for this left hand side. Let us solve this one, RS plus RL the whole square. Then here we are going to take the derivative with respect to RL, hence Vs square is a constant, so let us take it outside. Vs square into d by dRL of the remaining term is RL only. Okay, minus Vs square RL into d by dRL of this expression Rs plus RL the whole square. To find the derivative of an expression like this, we need to know one more formula for the derivative, differentiation. That formula is written here. This formula is familiar for all of you because we have studied this formula from the higher secondary education onwards. D by dx of x raised to n, that is equal to n is the power, n x raised to n minus 1. Okay, let us use that formula to find the derivative of this function. We can conclude that n is equal to 2 in this case. So while solving this one, we can write it as n is here, n is equal to 2 into, sorry, don't need to write this one. Now we are applying this formula, so don't need to write d by dRL. Then x means this entire term, Rs plus RL raised to n minus 1, n is 2, again 2 minus 1 into, as we have multiple terms here, again we have to take the derivative here, d by dRL of the term within the bracket, that is RL plus Rs, that should be equal to 0. Okay, right. Now find the reduced expression for this equation. Now Rs plus RL whole square Vs square. What about d by dRL of RL, that is equal to 1 minus Vs square RL into 2 into Rs plus RL raised to 2 minus 1, in the sense 1. Okay, into d by dRL of this term is equal to 1, that is equal to 0. This I can take this entire second term to the right hand side. I'm going to take the entire second term to the right hand side. Then the expression will be, in the LHS we should have RL plus RL whole square into Vs square. If I take this one to the right hand side, this minus term becomes plus. Okay, 2 Vs square RL into Rs plus RL. Okay, got it. Simply I took the second term to the right hand side. Now I can cut this one and this one, then Vs square and Vs square can be cancelled. Then the remaining equation here is Rs plus RL, and in the right hand side we have 2 into RL. So I'm going to put or take the RL term to the right hand side. Here it is plus, so if I am taking to the right hand side, that become, this plus become minus RL. 2RL minus RL gives RL itself. Then the expression we are obtaining is Rs plus RL. That is the necessary condition. We discussed under topic maximum power transfer theorem. Maximum power will be delivered only if Rs and RL are equal. Rs equal to RL, and we proved it. Okay, thank you.